I'm John Greenwood. I'm a research fellow here at UCL, and my area of research is in visual perception or visual psychophysics. So my research is mostly focused on our peripheral vision. It's interesting because the brain devotes a lot of resources to the centre of our vision, the fovea, and considerably less to the peripheral vision out here. So if you think about the kind of richness of the visual scenes that we encounter, then there's a lot of detail out here that the brain has to process with quite limited resources. So the brain takes a lot of interesting shortcuts there, and a particularly interesting phenomenon here is what's known as visual crowding. Now if you take I can show you this on the screen. If you take a letter, for instance, and you're looking directly at it, then it's easy to see. If you were to fixate, however, on this cross and look at the letter in your peripheral vision, that's considerably harder. What you can do is to make it bigger, and that just overcomes the limitations of our visual resolution. But what's interesting in peripheral vision is that when you add other letters to the side, it becomes considerably more difficult to identify that. So if I asked you now to tell me what the middle letter was, you'd have trouble. That's something that you could have seen previously, and so this is showing us that there's some kind of integration that goes on in clutter. So the research question is, why does crowding occur and how does it work? One thing that we found thus far in looking at these kinds of questions is what crowding does to the appearance of objects. So, for instance, if you look directly at this stimulus here, what you'll see is a little patch of noise, this sort of blobby, flickering noise, and it's surrounded by these oriented elements. What happens though when you fixate and when you look at it with your peripheral vision, if you look at this cross here, is that you should see that the noise starts to become oriented. It might look like there's 5 little oriented patches, it might look like there's just a single texture overlaid across that whole thing, but certainly you lose a sense of the noise being there. So what we think is happening is that the brain is taking the dominant orientation and applying it across that whole region. It's a kind of simplification of the visual field. So what you end up with is this sort of gist of what's in that area that's perhaps more efficiently processed by the limited resources that we have in the periphery. So you get a sense of what's there without actually having to encode everything necessarily. There's a few reasons why this kind of research is important for society. The first is simply to understand how we see the world. If you think about crowding, for instance, then this is something that affects your vision over 95% of your visual field. And it affects the way that you see all kinds of things, for instance, the orientation of a line, the direction of motion, the colour of a patch or a face. All of these things are disrupted by clutter. So if you want to understand vision, we need to understand crowding. It's also important because crowding is elevated in certain visual disorders. So the most well-known is amblyopia, or what's often called lazy eye. When you have one of the eyes diverted inwards or outwards, what you see in that diverted eye is a great deal of crowding when they look directly at something. It's also been suggested that there is elevated crowding in dyslexia, and you can see there, for instance, that there's likely to be issues with reading cluttered text. If we can then understand crowding, then we can more properly, more efficiently design reading materials and things like that that avoid these effects of clutter. We can design diagnostic tests and tests to evaluate various treatment programs.